So can anybody respond? Are you able to see my screen here?
Yes, sir, it's visible.
Okay, thank you. Let me put a screen mode. Yeah. Okay. So as I've already mentioned, this is a session three. In previous two sessions, in first session, we what we did was that we will solve recent 2022 questions, and the session two was like we discussed about unit autographs. Now this is session three. We will discuss the critical flow. Okay. Before proceeding the critical flow, let's look at the specific energy. Okay. So what is the specific energy? So it is an energy per kg of water. So remember, energy per kg of water at any section of a channel measured with respect to the channel bottom. See, if you take any channel, it will have a water level like this, and it will have a depth y, and it will have some velocity head also. So let's say this is a datum we consider. With respect to the datum, there will be z also. So now the specific energy, what we do is that we will neglect this, we will consider bed as a datum. So we will neglect this z and we will consider bed as a datum. This is our datum, and we will calculate the energy with respect to the bed. Okay. So energy per kg of water at any section of a channel with respect to the channel bottom, that will be y. So this is a full form. It can be written as y square by 2g also. So as we know, q equal to av, so v equal to q by a. So by replacing that, you will get this q square by 2a. See, writing in this form will help us in solving the questions. That's why I directly written this q square by 2g into a square directly here. But remember that this will be like y square plus, sorry, y plus v square by 2g. So this is a specific equation. Let's say look at this general equation. This is a general equation for the total energy. So it has this datum head and potential head as well as a kinetic head. So from this equation, to to get this specific energy, we made the following assumption. One is that potential energy is zero. That is what does it mean? We consider that channel bottom as a datum. So indirectly we kept z is equal to 0, and we assume that channel slope is small. So when we put cos of, let's say, 0.005, it will be approximately 1 only. So that's why we assume that, let's say, channel slope is small. In open channels, like the channel slope will vary from 1 in 1000, 1 in 5000. In that manner only it will be there. So this is a fairly accurate assumption. And another important assumption is that momentum factor is 1, this alpha. So assume that channel has a uniform flow. In that case, a kinetic moment factor can be assumed as a 1. So from this general equation, we brought to the specific energy equation with this following assumptions. Okay. So I hope it is clear. So okay, let's say there are few important points I have noted down. Let's read one by one. For a given channel section and a discharge Q, the specific channel energy in the channel is function of depth only. So as you see here, it will be like Q square by 2g into a square. A is nothing but b into y. Let's say, for example, rectangle channel if you take. As I mentioned that, let's say the b is constant. We won't change this width of the channel. So then the specific energy will be of depends on function of y only. The functional relationship can be vary, like it can be f of x into f of x y, like that. So that is the first point. So E will be function of y. Here y is the flow depth. Okay. So now a plot which is drawn between depth of the flow y and a specific energy E is called a specific energy curve, as it's shown here in right side of the slide. See here, this is a sample channel cross section, and this is a specific energy curve. And this specific energy curve consists of one 45 degrees line as well as one specific energy curve. So here, for a given discharge Q, this is one specific discharge curve. And suppose if the discharge is varying, the specific energy will vary, and the corresponding curve will shift either to the right side or to the left side, depends upon the discharge. Okay, so if it is a greater discharge, it will move towards outward side. If it is a lesser discharge, then move towards the origin side. Okay, and this specific energy curve consists of two limbs. One is AC, one is AC, another is CB. Okay, another is CB, and these two limbs has a different functions here. So this particular limb, it is corresponding to the supercritical flow region. It's corresponding to the supercritical flow region, and this corresponds to the subcritical flow region. Let me add other people there. Yeah. So, as I mentioned that it has a two limbs. One is a supercritical limb. Another is a subcritical limb. So, for a given specific energy E, if you observe, there are two depths. One is y1, another is y2. If you clearly observe y1 and y2, so for these two depths are observed for a same specific energy, and these two depths are called as alternative depths. Okay, so this is a very important point. So this you can expect as a one mark question in gate, and it has been asked two times in a history. So we will also solve the similar question one. Okay, so these are nothing but alternative depths. Okay, so let's say how we can read this curve. Let's say any point P on the curve. Let's say maybe we can take this P, maybe P1. Let's say how we can read this will be P1. Let's say this P1 can be read as be here. Sorry, here let's take this P. It can be read as sum of pressure head Y plus velocity head V square by 2G. Okay, so it will be like, let's say here corresponding like here V square by 2G plus y2, that will be correspond to that P. So P, any point of P on the curve, the ordinates represents the depth and abscissa represent the specific energy, which is equal to sum of pressure head y and the velocity head v square by 2g. Okay, so it is how we can read here. Let's say here y is this one. Suppose if you draw similarly on a 45 degrees line, it will be like up to here only, but the point P here, the difference is v square by 2g. Okay, so that will be this, this will be E specific energy. Okay, so here one this star mark is very important. So for a given specific energy, we have a two possible depth. One is y1, another is y2. These two are called as alternative depths. So the smaller depth will be subcritical, sorry, supercritical, and the larger depth will be subcritical. And one another important point is that at point C dash or C or C double dash, the specific energy will be minimum for a given discharge, and this corresponds to critical state of flow. So what are the conditions for critical state of flow? The very first condition is Froude number is 1, so which is nothing but F r equal to V upon root over into G into D. Here D is a hydraulic depth. Okay, it's a hydraulic depth. Suppose if this becomes 1, then it will be for critical state of flow. And the second condition is that the specific energy is minimum for the critical state of flow, that is dE by dy equal to 0 for a given discharge Q. Okay, so given this critical state of flow, the velocity head will be equal to half of the hydraulic depth or a flow depth. We can say flow depth also in phi case. So suppose in this case y equal to v square by 2g is nothing but y plus d by 2. So for rectangle, suppose if you take for a rectangle, the hydraulic depth will be equal to y. Hydraulic depth approximately equal to y. So we, by substituting that, we'll get a EC equal to 3yc by 2. So how we can read? The minimum critical energy, critical specific energy is 1.5 times of critical depth here. Okay. So before solving these questions on the particular topic, let's look at the two examples here. So one, these are the two local phenomena. So we often observe in channels. In the channels, one is like a free fall, free overfall. Another is a hydraulic jump. So can anybody say why do we create a hydraulic, like when this hydraulic jump happens? Like any idea in a practical case? Anybody like voluntarily you can mention like what situations you can observe, like practical situations you can observe this hydraulic jump. Hello,
Is dam example of hydraulic jump?
correct. And what else? Where else you can observe?
Because water is falling from great height.
Correct, correct. And this free overfall at just end of the section, end of this tunnel anywhere. Okay, so let's look at this how this given these are the condition, so how this specific energy will vary. Let's see. So given this is a channel and there is a sudden fall, I mean sudden fall, not a gradually. Okay, sudden fall. So given this sudden fall, then how much change in specific energy will you can observe? Let's say, as I mentioned, this will be subcritical region, this will be subcritical, this will be supercritical. Okay, suppose this is E1 and this is E minimum. Okay, so as the water flows along the channel and when it experiences the sudden fall, the energy available with the water will be dissipated slowly. Okay, suppose if there is no external energy supplied to the water, then the available specific energy with the water will be minimum, which is nothing but E minimum. Okay, and E minimum. So if you look at the E minimum, it will be here and initial maybe here somewhere. Okay, there is a delta E change in the specific energy. So specific energy. Okay, so and the depth, so initially it may have y1 depth, and as because of this sudden fall, if you take this section here, so that the depth will reduce to yc. Okay, so in this way we can look at the specific energy. So these kind of observations will be helpful while solving the um, channel width contraction or creation of hump. So this analogy will help you in there. Okay, suppose let's look at the hydraulic jump. So what is a hydraulic jump? It is a rapid change in the depth of flow from low stage. Always remember that it it appears from it happens from low stage to high stage. Okay, this will be like a y1 and this will be like y2. Sorry. Okay, from low stage to high stage, that results in usually abrupt rise in the water surface. Okay, so it can also be read as that the rapid change in depth of flow from supercritical to subcritical. It can also be read in that way. Okay, so the depth before the jump is called initial depth y1, and the depth after the jump is called sequent depth y2. So in the previous slide we talked about one depth. So what is that? Alternative depths. So in the alternative depths, that both the depths will have a same specific energy, but in a hydraulic jump these are called as sequent depths. What is that? One is the initial depth before the jump and another after the jump. This is called sequent depth, and these two sequence depths will have a same specific force. Okay, same specific force. Okay, here if you look at y1 and y2, but here it will be different. Here y1 is here and y2 is here. Okay, but y1 has another corresponding alternative depth, that is y2 dash. Okay, so this difference has to be remembered clearly. So alternative depths will have a same specific energy, whereas sequent depths will have same specific force. Okay, so the initial and sequent depths are actual depths before and after jump because of energy loss delta E. Okay, let's solve one question from gate 2018 set 2. Okay, gate 2018 set 2. So the question number is question number 13. So for a given discharge in an open channel, there are two depths which have a same specific energy. So these depths are known as. So anybody want to have a guess?
Sir, sequent depth, but alternate depths are also sequent depths.
No, just now I have shown you that. So the sequence depths will have a same specific force. Okay, whereas alternative depths will have same specific energy. Okay, so what is the critical depths here? Anybody?
Maximum energy.
Huh?
The maximum energy.
No, it is a depth corresponding to minimum energy, corresponding to E minimum. Okay, and what is the normal depths? Any idea? Like you can guess here. I did not discuss, but you can guess it. What, like what is the normal depths? So this normal depths is depth of depth of flow in a channel provided flow is uniform. Okay, so what is the answer here? So answer will be alternative depths. You can look at here. Maybe this example will give you a better idea. So this is E1, and corresponding to E1 we have one depth y1, and for the same specific energy we have y. So y1 equal to y2 dash. These are the alternative depths because these two have same specific energy. So corresponding to y1, what is y2? So y1 equal to y2. Y2 is here. Maybe you can look at here. Y2 is here. These two are sequent depths because same force, specific force. Okay, am I clear?
Yes, sir.
Okay, thank you. Let's solve another question. Okay, so I'll give 1 minute time for this question. Like you can guess it here. So let's read the question. So this I have taken from gate 2018 set to question number 23. A 10-meter wide rectangular channel. So here wide is width. Rectangular channel carries a discharge of 20 meter cube per second under the critical conditions. It means that E minimum. Okay, keep that in mind. Using G equal to 9.8 meter per second square, the specific energy in meter up to only two decimals place is. See, you always clear must remember when there is a like a fill in the blanks question, you must read to what decimals they've been asking, whether they are asking for 2, 3 or 1 decimal. So accordingly you answer. Suppose sometime if they ask for 3 decimals, if you put only 2, it may be a problem for you. Okay, so yeah, so anybody wants to guess how it can be solved? Just you can it can be wrong, but you just have it like you can say here how we can solve here this question. Let me write the given data. What is there? Given width b equal to 10 meter. Okay, and the discharge q equal to 20 meter cube per second. Okay, and g acceleration due to gravity is 9.8 meter per second square. So what is the formula for specific energy? Specific energy E equal to y plus v square by 2g, nothing but pressure head plus velocity head. Okay, so okay, so how it can be solved? Now you want to guess? Anybody? So
Velocity is equal to discharge by areas.
correct, velocity equal to discharge by area. Okay, but do we know why? No, but remember here there is one point that is given under the critical conditions. So let's look at this point and solve. So given that d equal to dy is 0, that is minimum. Okay, so when e is minimum, that the differentiation like this is you must know from mathematics. So d equal to dy 0 when e equal to minimum, and the corresponding depth will be yc. Okay, let's solve this question. Like suppose let's say, so what will be dE by dy? So 1 so in v square it can be written as q by a square na, q by a na. So let's write q square by 2g into y cube. So here small q is equal to capital Q by small b. So this is discharge per unit width. Okay, and okay, maybe I can solve more detail here. 1 by y square. So d by dy of 1 by y square is how much? Okay, tell me, can anybody guess? Minus 2 y power minus 2 minus 1. It will be like minus 2 y power minus 3. Nothing but minus 2 divided by y3. Okay, this is how we got this one. So provided this is 0, so 1 minus q square by g into y cube. Okay, it will be yc, sorry, this is yc equal to q square by g whole power 1 by 3. Okay, so let's put what is q, 20 by 10 whole square divided by 9.81 whole power 1 by 3. Can anybody say the answer how much will be? Quickly you can calculate and say the answer. So maybe parallel we can put this one. So now E equal to yc plus q square into 2g yc square. So we can substitute here and we can get the answer. So are you able to solve? Like, did you follow? Anybody? Okay, let's see the solution. Okay. So as we know, the specific energy in the channel is E equal to y plus v square by 2g. So this is a flow depth plus velocity head. So this v can be written as q by a, so q square by a square. And as we know, so given this is a rectangular channel, so the area will be b into y. So I'm just reshuffling the term q equal to q by b. Okay. So I'm sorry introducing that. So it will be q square by 2g into y square. Okay, this is a specific energy equation. It has given in the question that under the critical condition, it means that E minimum. So as we know in the maximum minimum principles from the mathematics, so the slope of this energy curve with respect to y will be 0 when E equal to E minimum. Okay, suppose if you take any function, if their slope is 0, it will have either minimum or maximum, depends upon the value. Okay, so this you might know from the mathematics, like plus and mathematics. So by differentiating this energy, specific energy with respect to y, we will get this equation. So because dy by y equal to 1 minus q square by g is a constant, so I have already shown you how we got y cube here. So how you dy of 1 by y square will be minus 2 by y cube. Okay, so already 1 2 is here, so again we got 2, so 2 2 get cancelled, so it will be q square by g y cube. So this equal to 0. Now just shuffle the terms and we got this value. So the answer will be 0.74 meters. Okay, so given this is a yc and this is a depth at E minimum, which is called critical depth. So as we know, so these are the equation. Let's substitute this yc in this specific energy equation. So this will be yc plus q square by 2g into yc square. So like there is a direct equation form also, 3 by 2 yc, 3 by 2 yc. So otherwise we can get, how we can get here. So in this way also we can get, we got yc plus yc by 2. So that will be 3c by 2. So this is the final equation. So up to how many decimals they asked? 2 decimals. So answer will be 1.11 meters. Okay, so like is anybody have any, like, do you have any doubts, like anyone? See, in this session I'll use only 3 equations. So what is our first equation? Only 3 equations, you must remember. 3 equations only. Okay, first one, E equal to y plus b square by 2z. Okay, and you know v equal to qa. So you can directly write it as q square by a square into 2z. First equation. Second equation, d by dy equal to 0. So which gives ec equal to 3 by 2 yc, and yc equal to q square by g into whole power 1 by 3. If you know these 3 formulas, then you can definitely able to solve these questions from this particular specific energy and critical flow concept. Okay, just note down these formulas and you will able to solve. So let's see the next question. So this question I have taken from GATE 2019 CE set 1. The question number is 13. So you observe that previous also question number 13, now also that question number 13. So you can blindly follow where question number 13 may be allocated for the open channel only. So the question is as follows. In the rectangular channel, the ratio of velocity head to the flow depth for a critical flow condition is. So what is the ratio? So so they, so they ask to calculate the ratio of velocity head to the flow depth. Okay, so it can be 1 by 2 or 2 by 3 or 3 by 2 2. So can anybody guess how much will be the answer and how we can solve? Though it is answer is available here, but you can say in term, like, voluntarily. How many of you are there in the class? Like, so are you understood? Okay. So Rudra Bhaskar told is C. Any others want to add? Others want to add anything? Maybe Udita or Govinda. So the answer is is here. I already shown, but let's okay. So as we know, E minimum equal to like yc plus q square by 2z into yc square. Like it can be E or E minimum. So as we know, sorry, as we know, specific energy equal to y plus v square by 2z. So what is v square by 2z? Velocity head only. Okay. So the question is that the ratio of velocity head to the flow depth for a critical flow condition. So as we know, the relation yc equal to q square by g by 1 by 3, or yc cube equal to q square by g from the previous slide. So I told only three equations we should remember for solving all these questions. Okay. So let's see. This is the equation I have been showing from the starting of the session. Yc equal to q square by q square by 2 into yc square. Okay. So as you know, q square equal to q square will be yc cube into g. So substitute here. So g will cancel, and the square cube will cancel. So remaining will be yc plus yc by 2. And you observe this circle. So this will be velocity head, and this will be flow depth. So the ratio will be yc by 2 divided by yc. So it will be yc by 2 into yc. It will be cancelled. So answer will be 1 by 2. So option A is correct. Okay, don't get confused. So we may tend to put this as answer, but it is asked to calculate the ratio of velocity head to the flow depth, not flow depth to the velocity head. Okay, so am I clear? Like, please respond. Am I clear?
Yes, sir.
Okay, let's proceed to the next question. So this question is taken from GATE 2017. So this question requires some effort, but it is worth to put. So this is 2 marks question. So see, again we'll use the same three formulas here. Left and right we'll use the same two formulas, but with a little concept. Okay. So I have already told you that this is a specific energy curve, for example. Okay. So, pardon my very bad drawing here. This one. This is Y2. So I have already shown you. This is supercritical region. This is subcritical region. Okay. Keep this figure in mind. Let's read the question. So gate 2017 set gate 2017 set two question I have taken. This is question number is 46. So a 1 meter wide means width rectangular channel carries a discharge of 2 meter per second. Let's write the given data. What is the width? B equal to 1 meter. And what is the discharge? Q equal to 2 meter cube per second. Okay. So what they have given the specific energy depth diagram. So the specific energy depth diagram is prepared, this one, for this channel. Okay, they have already prepared this specific energy curve diagram, and it is observed in the diagram that corresponding to particular specific energy. Suppose this is a one specific energy they have considered the subcritical depth. So which is this one is twice the supercritical depth. Let's say subcritical depth as y1 and the supercritical depth as y2. So before let me ask you here, what is a subcritical and supercritical flows? Anybody have an idea? Gayatri. Sorry, there's a lot of noise here. Beta. Ah, yeah. Sorry, I know the voice will be clear. Let's. So yeah, can anybody say what is the like a subcritical condition and what is a supercritical condition in terms of Froude number? Guess like it can be wrong also, but you can guess. Anybody voluntarily like maybe Govinder or Udita or Likita. Let's say
It's
if we consider
critical flow is always less than one
which
fraud
is less
number.
than one Froude number. Froude
Yeah,
number will be less than one. For a supercritical flow,
it's
Froude
more
number
than
will be greater than one. Why? In supercritical flow, what is the formula for Froude number? V equal to V upon root 1 to Gy. Okay, the velocity will be is very high and depth will be smaller. Okay, whereas in subcritical flow, the velocity will be small. Okay,
Depth will high.
depth is high. Okay,
High. Yes, sir.
as you can see from the graph here. Okay, that is the reason why you will get less than one, and why that is why reason will get one greater than one. Suppose if I ask you this question from the hydraulic jump perspective, so let's say this is a hydraulic jump. So where you can observe supercritical depth, this is a supercritical jump. So if you divide this hydraulic jump section, this will be subcritical zone, and this will be supercritical zone. So this point you must remember, na? Okay. So as the definition itself says that rapidly change in depth from low stage to the high stage, like smaller depth to high depth. Okay. Okay. That is a trivial details. Let's get back to our question. So now they told that y1 equal to 2 times of y2. Okay. Because the subcritical depth is twice the supercritical depth. So now they ask you to calculate what is the subcritical depth in meters up to 2 decimals. So always remember when there is a fill in the blank question, you read carefully read up to what decimals they asked, whether 2 decimals or 1 decimal or 3 decimals. Okay. So let's as we know, alternative depths have same specific energy. That means that E1 equal to E2. Okay, which is nothing but let's say y1 plus q square by 2g y1 square equal to y2 q square by 2g into y2 square. This point is clear. Uh, this point is clear. Can anybody please respond?
yes, sir.
Okay. So as the definition says that this same this on this definition we solved one question number 13 from GRID 2018. So the alternative depths will have same specific energy. So with the same principle, E1 equal to E2. So here one is Y1 will be Y1 will be subcritical and Y2 will be supercritical. Okay. So this is a thing. So let's solve the question. So now I'll equal this equation, these two equations, and let's substitute Y1 equal to 2Y2. Okay. Substitute Y1 equal to 2Y2 because it has given subcritical depth is twice the supercritical depth. Okay, so it will become 2y2 plus q square by 2g into 4y2 square because y1 whole square is there na? So 2y2 whole square, it will become 4y2 square, which is equal to y2 plus q square by 2g into y2 square. So let's rearrange the terms. Maybe I can solve here. 2y2 plus q square 8g, maybe I can put it 2 into 2g into 4y2 square equal to y2 plus q square by 2g y2 square. So bring the y2 both y2 on one side, to y2 equal to y2 into q square by 2g y2 square minus q square by 2g into 4y2 square. Okay, so it will be y2. So let's take common q square by 2g as 1 by y2 square minus 1 by 4 y2 square. Okay, so it will become y2 equal to q square by g 2g. So y2 square also we can take common, so it will become 3 by 4. So I understood how it came. So it will be like 1 minus 1 by 4, so it will be 3 by 4. Okay, so they can take this as this side, and it will be y2 cube will be equal to q square by 2g into 3 4. Okay, so this will be y2 equal to 3/4 of q square by 2g whole power 1 by 3. So once you able to solve this, get this equation, the question is straightforward only. Okay, is it clear? Like maybe even though I have solved step by step, am I clear? Like, is there any confusion? If there is any confusion, I can solve one more time. So see, from the starting, we are using only the same three equations: E equal to y plus v square by 2g, EC equal to 3 by 2 IC, and YC equal to q square by g whole power 1 by 3. So now in this question also, this is a very important question, and it is for 2 marks. You can expect the similar kind of questions. Okay, so is it clear? Like, please respond. Like, then only I'll be able to understand whether you were like listening or not.
Yes, sir.
Yeah, thank you. So just we know this formula now. Substitute. So as we know, q equal to q by b, it will be like 2 by 1. So you can submit here 2 by 1 whole square. 2 into 9.81 is like acceleration due to gravity, so it is not given, so either we consider the value. So this is one important point. So these kind of standard values, if they are not given, you can assume like acceleration due to gravity, but most of the cases they should give, but in this case they have not given, so maybe you can consider. Okay, so 3/4 into 2 by 1 whole square by 2 into 9.81 whole power 1 by 3. If you solve this particular thing, you will get a 0.534 meter square. Sorry, 0.534 meter. See, in the gate you need to solve with the help of virtual calculator only, not with the scientific calculator. So always try to um, do bring these terms in a simple term. So 0.23 by 4 we know what is how much, 0.75 into 2 by 1 is will be 2 square, so it will be like a 4. And even this denominator is like zero point 0.2 into 9.81 na? So this 4 will were cancelled. Okay, or otherwise this will be 3, sorry, this will be 3. So you always bring into this smaller fraction, so that it will reduce your time in a computation. Otherwise, if you're entering all these terms in calculator and pressing, it will take a lot of your time. Okay, so and always remember this 2g value is a standard. Maybe you can buy hard, it will be like how much it will be. So 2 1 6 18 19, so 19.60 is a standard value, you can remember always. Okay, and so you will get a 0.34. So but the question is to calculate the subcritical depth, so which is nothing but y1. So y1 equal to 2y2, so 2 into 0.534, so the answer will come out to be 1.07 meters. Okay, yeah, maybe I'll stop here because these are the like some important point questions we have solved, and we played with the equations here. So maybe I'll just interact with you here. Yeah. So Gurvinder Singh, so did you understood like at least a few point here? So in this session, we have only used the 3 points, three question, three formulas. I've already shown you.
Yes.
If you remember these three equations, your job is simple. Okay. So yeah.
Okay, sir.
So yeah, Likita.
Yes, sir.
So did you understood like all the questions? Like four questions were solved.
Yes, sir, I understood.
Thank you. Artis, Artistya. Sorry if I pronounce it wrong.
Yes, sir.
So did you understand? Like I hope I think you have joined little late, but did you
Yes, sir.
did you understood the questions? Like see, no need to feel feel as like a sir and a student. Like I'm also a student here, so I forgot to introduce myself. Like I'm a PhD student here, so you can
Okay.
openly talk and discuss. This should be an interactive session rather than the one rather than the
Okay.
teaching session. Okay. So Naresh, Naresh, are you there?
Yes, sir.
So did you understood
Yes, sir. Yes.
so Arnav Kumar? Okay, fine.
I understood, sir.
Okay, thank you. Uh, this is about today's session. In the next session, we will discuss about the dimensionless number, like a Froude number, Reynolds number, and Nat number, Euler number, and all. And we'll solve some questions on similitude as well, like model and prototype questions, which have been very important, but we have been neglecting these questions. But these questions will cost us simple 2 marks. Okay, so and these are the very simple questions.